Welcome back to Teaching Statistical Thinking. In our previous video, we learned about graphics to describe the distribution of a single variable using histograms and box plots. Today I'm going to take that a step further to how do we describe the distribution of the variable using number summaries, and today specifically summaries for the center of the distribution, the mean and the median. I'll be using the same four variables that we started with last time and then moving again to our real movie data set. So let's go. Recall from the last video that in our first variable we had a variable that had a 3, 2 4s, 3 5s, 2 6s, and a 7. To draw the box plot, we needed the 25th, 50th, and 75th percentile. The 50th percentile has a particular name, and it's called the median. The median is the 50th percentile. It's the point at which half the data observations fall below and half fall above. For our first three variables, we see that the median is 5, and for our fourth variable, the median was 4. In the box plot, the median is the center vertical line in the box. Recall for our fourth variable, the 25th and the 50th were the same. A second measure of the center of a distribution is called the mean, and it's the arithmetic average. Rather than being the point where there's 50% above and 50% below, the mean is actually where the histogram would balance if you put a fulcrum on that x-axis. It's also called the arithmetic average, and I'll show you how to calculate it in just a minute. What I'd like you to notice is that for each of these four data sets, okay, where the histogram would balance is exactly the same place at 5. To calculate the mean, we simply sum all the observations and divide by the number of observations. In each of these four variables, the sum of the observations is 45. Each of our variables has 9 observations, so the sample mean, indicated by x bar, is 45 divided by 9, or 5 in each case. Now let's look at the production budget of our movies data set. Recall that the production budget was the millions of dollars required to produce that budget, or to produce that movie. Okay. We see that we have a very skewed histogram. The median, or the 50th percentile, was 37. But if we add up all of those budgets, 8 plus 25 plus 125 plus 25 plus 50 plus all the others in the data set, and divide by the number of observations, 134. While there are 136 movies in this data set, 2 are missing their budgets, so we divide by the number 134. When we do that, we get a mean of 53.5. I'm going to write this formula a little bit more generically. If we number our observations 1, 2, 3, 4, 5, on down to 134, I'm going to call each of these numbers generically x sub I. So this would be x1 plus x2 plus x3 plus x4 on up to x 134. Okay. And then I would divide by 134. To take it even a bit more generically, we often write it as the summation from I equal 1 to n, where n represents the number of observations in the data set, x sub I divided by the number of observations. We indicate the mean of our sample by a capital X with a bar. And that's how we calculate the mean of a variable. Notice again that for the budget, 37 was the median. However, the long right tail pulls the median or the mean to the right at 53.5. Now I want to go back to our categorical variables, genre. We had comedy, action, fantasy, drama, etc. On a categorical variable, it doesn't make sense to do these arithmetic functions on a categorical variable, so the mean and median don't make sense. I can order these categories any way I like. I just chose alphabetical. While the mean and median don't make sense for a categorical variable, the mode does make sense. The mode is the value that is taken most often by a variable. For our genre bar chart, we see that the action movies has the highest bar, meaning it has in the most area, meaning it's the mode of the genre category. Almost 25% of our movies were action movies. So that's an introduction to the basics of number summaries for the center of a distribution. Practice on those before the next video, and then we'll take it a step further and talk about number summaries that describe the spread of a distribution. See you then.